Hey guys, welcome back to Business Statistics. This is going to be the review for modules 4 and 5. I'm also going to be putting out a review for exam 1. That will come later this week. But this is the review for modules 4 and 5, so this is going to be very similar to the companion worksheet that I did, but it's just going to be more problems for you to follow along, because I know some people had trouble with the modules 4 and 5 quizzes. Check the announcements tab if you haven't already looked. There will be an important announcement regarding the modules 4 and 5 quizzes in accordance with exam 1 as well. So check that out. But without any further ado, let's get into the review. I'm going to try to make this video as quick and concise as possible. Try to hold it to about a half an hour. So let's get into it. Alright, so if you are following along with the worksheet, which you should be if you're watching the video, you can find this video in course materials, content, and then modules 4 and 5. Okay, so it'll just be named something like modules 4 and 5, more problems. Okay. And it's not going to have the red lettering in or anything like that, okay? That I just put in to save some time. Alright, so during one holiday season, the Ohio Lottery played a game called the Stocking Stuffer. Prizes ranged from $1 to $1,000. Shown here are various prizes and the probability of winning each prize. Use the data to compute the expected value of the game, the variance of the game, and the standard deviation of the game. So this is just going to be testing our knowledge of those formulas for kind of the simplest form of the discrete probability distribution. So our summation formulas. So I'll just go ahead and remind you of those. Now granted, you will have these on a test. So I will be giving you these formulas on the test, so you won't have to memorize them per se, but you will have to know them, or know how to use them, I should say. Alright, now let's get the pen to work. Okay, so the formula for mean is just going to be mu is equal to the summation for all x of x times p of x, okay? And then the formula for variance is just going to be the sum for all x of x squared times p of x, okay? And then furthermore, we know that sigma, which is the standard deviation, is just the square root of the variance, okay? So what this means is, so for mu, we're going to be taking x times the p of x for all x. So we look in here and we have an x column that is prize. We have the probability of winning that prize. And then we're just going to be multiplying each one of those together to get some number. Okay? So for instance, this first one, we have $1,000 times probability of winning that $1,000 ticket, 0.00002. We multiply those together and we get one component of this sum. We just march down the line. 100 times the probability of winning that 100 of 0.00063, and we get this. We add all of these up. We do this over the whole distribution. We add all of these up, and it sums to this. So this is going to be our mu. Just got a phone reminder. Sorry about that. Anyways, so that's that. So I feel like mu is fairly intuitive on how to calculate, and maybe if it's not intuitive, it's at least manageable, kind of from a tabular sense, from like using a table. Okay. Now the variance. I didn't even write the formula correctly. Okay. So the variance is this minus mu squared. Good to know. Good to know. So basically, or also what I'll do is I'll post just the answer key to this as well. Okay. But you are going to want to follow along with a video to just see how I do these calculations. Okay, so variance is a little bit different in that we are going to do the same sort of summation where we're taking a square of x times p of x, and then we're adding them down. But after the whole thing is done, we have to minus off the square of mu. So basically what we're doing, what this column is for right here, or right, and totaling to, is going to be this portion of the formula. Okay, so this 20 right here is just, it really is just 1,000 squared times the probability of x. Boom, 20. Okay, 100 squared, so 10,000 times probability of x equals this. 20 squared times the probability of x equals 1.6. So we add all these up to get this 29.353 number. Okay, so it's going to get us sigma squared is equal to 29.34535 minus mu squared 0.60155 squared. So again, this value is from the table, and this value is our mu squared. Okay, we go ahead and we work that out, and this is going to shake out to be 28.98349. So this is our variance. Okay, and then that's a point. And then if we wanted to know what the sigma is, or the standard deviation, we would just say, well, it's going to be the square of our variance, or the square root rather, 0.98349, and that is equal to 5.38363. Okay, so it's just testing your grasp of the formulas. So our mu formula and our variance formula, and then of course, standard deviation is just going to be the square root of variance. Okay. So you guys, as always, let me know if you have questions. I'm here to help, here to answer those questions for you. All right. According to the National Association of Insurance Commissioners, the average annual cost for automobile insurance in the United States in a recent year was $691. Suppose automobile insurance costs are uniformly distributed in the United States with a range of from 200 to 1,182. Okay, so the first thing that we need to do is we need to ask ourselves, well, what is the most important thing that we just read here? Now, the most important thing is that we saw that it's uniformly distributed. Okay, that is going to be given to you in a problem, right? So once you see that keyword, then you know what formula set to use. Okay, so then all we're going to be doing is looking for our formula set for the uniform distribution. So the uniform distribution is always going to be in the format of f of x. Uh-oh, what is going on? What is going on down here? Okay, it's always going to be in the format of f of x is equal to 1 over b minus a. I have no idea what my tab is doing there. 1 over b minus a, and that is defined for x from a to b. Okay? And so and b and a are just the endpoints of the range for which it's defined, right? So then, for our case here, we're going to have f of x is equal to 1 over 1182 minus 200, defined over that same range. So I'll just rewrite it here. F of x is equal to 1 over 982, and that is defined on the range of 200 to 100 or to 1,182. Okay, so that's our function. All right, so that's going to look like a graph from 200 to 1182 that has a constant height of 982. Okay, so this is our probability density function right there. Okay, our x, and I guess we can call that our y. All right. So that's kind of what it's going to look like if you guys remember us doing that before. So, and we also have a given standard deviation function, which is just going to be, I'll just write it up here, b minus a over the square root of 12. Okay? All right, so the first question asks, what is the standard deviation? Well, we know that it's b minus a over the square root of 12. What is b minus a? Well, we know that that is 982 divided by the square root of 12 equals 283.48. So great. So that's done. What is the height of the distribution? Well, we know that the height is 1 over 982. That's just our function value. That's our height. What is the probability that a person's annual cost for automobile insurance in the United States is between $410 and $825? Oh, another formula that I didn't write down that I ought to is the formula for how we calculate probability. I guess I'll just write it down here when we do the problem. So our formula, which this will also be given to you, is the probability from A to B. So x is between A and B, or sorry, x is between C and D rather, is equal to D minus C over B minus A. So then for our problem, that's just going to be the probability that x is between 410 and 825 is equal to 825 minus 410 over B minus A, which we know is 982. So we just get 415 over 982, and that is equal to 0.423. Okay, then D asks us, what is the probability that a person's insurance costs is less than $100, or is $100 or less? Okay, so this is more of a logic question than it is a math question, right? So we could go through our formula and we could solve this out, but what do we know? We know that this function is only defined from 2 to 1,182. So we just automatically know, well, we can't have a value that's 100 or less. So probability of x less than 100, 0. Okay, I would be ready for a question like that. It's going to test whether or not you know how to assess the function, given that it's defined over a specific range. Okay. All right. Then what? Then you are on a budget and can spend at most $300. Assume your insurance is randomly taken from the distribution. What's the likelihood you are covered? Okay. And that's just saying, okay, we can spend at most $300. So, given that we're working within the range, at most $300, we're then looking for x is less than 300, right? Okay, and then that's going to equal the bottom of the range. So 200 is less than x is less than 300. And we have a formula for that. We just use that. So that's going to be our D minus C over our B minus A. So D in this case is going to be 300. C is going to be 200. And that's going to be over our 982. So it's going to be 100 over 982. And that is going to be 0.102. As always, guys, let me know if you have questions. I'll be happy to answer them. We're going to move on to the next problem. Number 3, the worst team in the NFL is the Cleveland Browns. We know that when going into any football game, they have exactly a 20% chance of victory. Assume that each game is independent of one another. No games have been played yet, and the Browns play a 16-game season. Also assume that there's no such thing as a tie, okay? So we just have two outcomes here. We have a win or a loss. Okay, so then the first question becomes, what distribution are we working with? Because this isn't one where we are given a named distribution. We have to determine what the probability density function is. We have to determine what the distribution is. Okay, the first thing I notice is that we have a 16-game season, so that would be a fixed number of trials. We have two outcomes. We have a win or a loss. Okay, we have independent probabilities, meaning that on each football game they have exactly a 20% chance of victory or a 20% chance of success. And those probabilities don't change. They remain constant. Okay, so that's the exact recipe for a binomial probability, a binomial distribution function. Okay, so those 3 or 4 factors that we just mentioned: fixed number of trials, binary outcomes, right? So 2 outcomes. The probabilities are independent. They don't depend on anything before or after. And the probabilities remain constant, okay, at 20%. So we know that it's binomial because of that. So now we just have to answer our questions because we've adequately defined it as binomial. And so then we can write out our formulas for binomial. Probability of x is equal to n choose x times p to the x q to the n minus x, right? And that's just the combination for number of victories or number of success, probability of success raised to the number of successes, times probability of failure raised to the number of failures. And then we have a mu that's defined as n times p, and a sigma that is defined as the square root of n times p times q. All of this stuff will be given to you on a test. So yeah, that's that. Okay, so A. What is the probability the Browns win at least half their games? So that's saying, well, at least half their games would be at least 8. Okay. So what we're going to do, this would be the probability that they win 8 plus the probability that they win 9 plus the probability that they win 10. Okay. You could also look at this like 1 minus the probability that they don't win 8 games. So 1 minus the probability that they win 7 or less. You could do it that way, but it's all going to depend on what you want. Okay. And we're going to see why that is. Okay. So all the way up to winning all the games. So the way that we go about doing this, whenever we're going to be doing like a large grouping of these, we don't really want to use this calculation. We want to use the tables for it. And again, you will be given the tables on the test. Okay. So let's bop on over to the tables. Now, when you're practicing this, these tables are available on Brightspace. So I've mentioned probably numerous times in previous videos where to find these tables. So I think it's in course materials, content, resources, I think, without looking. So you find these tables. We're going to find binomial table. And we have to find the binomial table with the correct number of n. So this is n equal 2, n equal 3, n equal 4. So we want to find n equals 16 right here. N equals 16. And so then what we do is we march over to the probability of success. Probability of success in our problem is 0.20. And then we're just going to add up the probabilities that go along with that. So in our case, the probability of winning 8 games is 0.0055. Probability of winning 9 games is 0.0012. Probability of winning 10 games is probability of winning 8 is 0.0055. Probability of winning 9 is 0.0012. The probability of winning 10 is 0.0002. Okay? And the probability of winning 11, 12, 13, 14, it's not exactly 0, but it's so close to 0 that it's negligible. Okay? So that's why they actually just include, those in the table. So for purposes of our calculation, we don't have to calculate that. Okay. Or so we don't have to know anything past the 4 digits here. All right, so we just add up those three numbers, the 0.0055, the 0.0012, and the 0.0002. All right, so let's go back here. And that is equal to 0.0069. So a really, really minuscule chance, so less than a 1% chance. And I do want it in decimal form. I don't want you guys putting things in percentages or whatever. It's just a lot easier to grade when everything is in the same format and it's in decimal form, okay? So we take this to 4 decimal places because that's what we have in the chart. But yeah, this is what we would expect. If they have a 20% chance to win any game, we wouldn't think that it would be very likely that they would just happen to win half of their games. Okay, so that makes a lot of sense. That kind of passes the sniff test. All right. What is the probability that the Browns win exactly 3 games? Okay, so we could find this on the table if we wanted to. If we went to the table, probability of X is equal. That should be an equal sign, equal to 3. We just go look at the table. And where would we find this? Probability of X is equal to 3. We march over to the 0.2, and we march down to where X is equal to 3, and we get 0.2463. Okay? 0.2463. So that's practice using the table. Okay, but if we wanted to practice using our formula, because I might ask you to do it using the formula on the test, this would be the probability that X is equal to 3, would just be 16, choose 3, all right, times 0.2 to the 3, times 0.8 to the 13, and that's gonna further equal 0.2463. 16, choose 3. You don't have to go through the big formula and do that. Use your calculator to do that. If you need to go through the big formula, go ahead and do that. Yeah, that's that. Okay, so we go to C. What's the probability that the Browns go winless? So winless would just mean probability of X equaling 0. We can also go to the table and look for that. But again, I might ask you to do it in another way. So we go to the table, n equals 16, 0.2. Probability of them winning 0 games is 0.0281. 0.0281. If we wanted to calculate that, we just say probability of 0 is 16, choose 0, times 0.2 to the 0, times 0.8 to the 16. Okay, 16 choose 0 is just 1, 0.2 to the 0 is just 1, and then 0.8 to the 16 is going to be the 0.0281. Cool. All right, and then D is just, hey, can you use the formulas that are given? So our mu's are n times p. So n is equal to 16. And p is equal to 0.2. So our mu, or the expected number of games that we're going to win in a season, would be 3.2, right? Notice this isn't a whole number, so it's not a real number. We can never, ever win 3.2 games. We can only win a discrete value, right? We can only win 3, 4, 5, whatever. But this is our average, okay? This is our mean. And then what is our sigma? Well, we have a formula for that, n times p times q, and the square root of that. So 16 times 0.2 times 0.8, and that is going to shake out to be 1.6. That's that. All right, guys, let me know if you have questions on that as well. All right, on to 4. A business statistics professor looks for student volunteers to come to the board to answer questions without giving out extra credit. He finds that the number of students who keep eye contact when he looks at them without looking away, pretending they're looking at their phone, acting instead interested at what is on the board rather than what he is saying, is Poisson distributed with a mean of 3.5 over the 75-minute class period. So this doesn't apply to you guys as much. This is a joke that's directed at my in-class version of this class. But you guys probably have experienced this where the teacher looks at you and you sort of just like look away. Know that on the other side of that, it is very, very awkward for the teacher. So anyways, okay. So let's get on to the question. Yes, your business statistics professor is hilarious. All right. What is the probability that exactly 3 students maintain eye contact? So, all right. So before we even get into this, what is important here? Well, it's important. We saw that it said Poisson distributed, right? That's something that is undoubtedly going to be given to you. So it'll be given to you that it's Poisson distributed in a problem, right? You're not going to have to determine that. Like in the last problem that we did, where we had to determine if it was binomial or not, we're not going to have to do that for this. It's going to be given to us. It's going to be defined as Poisson. Okay, so that's that. So once we see that, we know, okay, well, we have formulas for that. Okay, we have a mu of x times e to the negative mu over x factorial. That's our p of x function, and we know that mu is equal to mu, and that sigma is equal to mu, or the square root of mu, which then kind of implies that sigma squared is equal to mu. Alright, so what is the probability that exactly 3 students maintain eye contact? Okay, so we're just saying, what is the probability of 3? Well, we can do that here. So mu is our mean. So 3.5 to the x, 3, e to the negative mu, negative 3.5, over 3 factorial. Okay, and if we run that calculation, we're going to get 0.2158. Okay, and you can also look this up in your table. So we would just have to go to our Poisson table where we have a mean of 3.5. So we're looking at the Poisson table here. We're just looking across here, trying to find 3.5. We found it. Okay, and then we march down to x equal 3. 0.2158. Okay, that's the same thing that we got here. So we're able to calculate it. We're able to use our table for that and whatnot. Okay, so B. He considers it a good day when more than 5 make eye contact. What is the probability that it is a good day? Alright, so a couple different ways to do this. Right, so we want to look at the probability that x is more than 5, which we could do by saying, well, the probability that x is equal to 6 plus probability that x is equal to 7 plus probability that x is equal to 8, all the way out to infinity. Or we could say, well, this is just 1 minus the probability that x is less than or equal to 5. And so then it's just 1 minus probability of 5 plus the probability of 4 plus the probability of 3, so on and so forth, all the way down to 0. Okay, so we're going to go ahead and do it whichever way you want, but I don't know, I guess I prefer to do the 1 minus version of it, just because then we have a finite set of values that we're adding up. Okay, and so then in order to do that, we would just go 1 minus, and then we go to the table and we look for values. So we're still looking at mu is equal to 3.5, and then we're essentially going to write down all the values from 0 to 5 that are in our 3.5 column. Okay, we're going to sum those up. So that's what we do. So 0.1322, 1888, 0.2158, 0.1850, 0.1057, and 0.0302. Add all those up, so it's 1 minus that. So it's going to end up being 1 minus 0.8576, or 0.1424 as our final answer. Okay, so that's that. Hopefully that made sense to you. That's very similar to the binomial in the way that we calculate it. Let's move on to see what is the probability that no students maintain eye contact. So that's a relatively easy one. So one, we can go to our table and we can just find that it's 0302. But if I asked you how to calculate that, you just plug everything into this formula. So probability of 0, that would just be 3.5 to the 0, e to the negative 3.5 over 0 factorial. So 3.5 to the 0 is defined as 1. E to the negative 3.5 is going to be something that we calculate. And 0 factorial is defined as 1, so this just equals e to the negative 3.5. And then we run that calculation, and guess what? We get 0.0302. And then what is the mean standard deviation for D? Well, that is relatively easy. I'll put D up here. The mean is just going to be mu. So the mean is 3.5. The standard deviation is, we'll just do the variance, I guess, next. The variance is 3.5. And then the standard deviation is just the square root of 3.5, which is equal to 1.87. And lastly, we will do our normal distribution problem. Okay, according to a recent study, the average monthly household cellular bill is $123. Suppose these are normally distributed with a standard deviation of 22.70. Okay, and then we have a list of questions to do. All right, so the first thing to notice is that we have a the first thing to notice is normally distributed. That's going to be given to you, right? So now you automatically know what formulas to use. The only formula that we've really used in this class is our Z formula, because we want to normalize things so that we can use our tables. Oh, I just put a Q. Sigma. That is sigma. All right. X minus mu over sigma. Okay. And so that's that. So for the normal distribution, that's that. And then for our specific problem, we know that mu, our population mean, is equal to 123, and we know that sigma is equal to 22.7 or 22.70. Okay, so now the route that we're going to take for this sort of thing is, okay, do we want to normalize things, meaning we want to turn our x's into z's in order to easily calculate probability. And what I mean by easily calculate probability is use our tables to calculate probability. Okay, so let's just go ahead and get into it. So A, what is the probability that a randomly selected monthly cell phone bill is more than 170? So we're first going to write this in terms of x. This is the probability that a randomly selected bill is more than 170. Okay, so that's that. But so now what we want to do is we want to turn these x's into z's so that we can use the table. So the way that we do that is we just say, well, that's just supposed to be z is equal to the x value, 170, minus the mu, 123, over our standard deviation of 22.7. And what we ultimately get for that, looking at my notes, is 2, so it's going to be 47 over 22.7, which is equal to 2.07. Okay, and so then this probability expression becomes the probability that z is greater than 2.07. So we're just putting it in terms of standard deviations, in terms of z values. Okay, and so then all we have to do then is, another thing that we have to do is we realize that when we use our z tables, everything that it's giving us is going to be a cumulative value. So then we can also further define this as, well, because the cumulative value is always the z less than probability. Okay, so then in order to get z greater than, we just say, well, this is just going to be 1 minus the probability of z less than 2.07. Okay, because the idea is that we have a normal curve here and we're looking for this top probability. But our cumulative table gives us this probability over here. Okay, so we want this, but we're given this, so we just take 1 minus what we have to give us our right-hand tail over here. Okay, so 1 minus our probability of z is less than 2.07. So we're going to go to our table. So we're still on Poisson, so we got to go find the normal table. All right, so here is our normal table, but this is the negative side of it. So let's go over to the positive side. So now we're looking for the value of 2.07. So we march down to 2.0. Okay, and then all the way over to the 0.7. Okay, so we're at 0.9808. Okay, so then we go back here, and we have 0.9808, which is just going to equal 0.0192. Okay, that's that. So that is our answer for 1, or for A. B, what is the probability that a randomly selected cell phone bill is 130 to 150? So this is a between kind of probability. So first we just write down what we have here. X is going to be between 130 and 150. And so then this is going to require us to do 2 z-scores. So a z-score for the bottom end and a z-score for the top end. So 130 minus 123 over 22.7. I don't know why my pen just did that, but it did. And that's going to equal something. And then I'll just call this z minus and then z plus or something. 150 minus 123. Alright, sorry about that. I got a phone call that I needed to answer. Alright, so we're finding both of these z-scores out. And we get 7 over 22.7 here. And we get 27 over 22.7 here. And so then the 7 over 22.7 is going to equal 0.31. Remember, that is not a probability. That is a z-score. And then this is going to be 1.19. So now our probability expression becomes the probability that z is between 0.31 and 1.19. Okay. And so then this is easy to deal with. So we're just going to be taking the larger probability minus the smaller probability. So it's just going to be the probability that z is less than 1.19 minus the probability that z is less than 0.31. So we go to our tables. So the 1.19 we want to find. So we go down to z 1.1 all the way over to 9. We get 0.8830. Okay. And then our 0.31 is 0.6217. So 0.8830 minus 0.6217 is equal to 0.2613. Okay, so that is that. And then our last question asks, what is the probability that a randomly selected cell phone bill is no more than $80? So that is just the probability that X is less than $80. Okay, and so then we have to find the z-score for $80. That's just going to be 80 minus 123 over 22.7, which is equal to ultimately negative 1.89. Okay, and then this is going to be fairly simple, so it's just saying the probability of z is less than negative 1.89, and that's just going to be a value that we look up in the table because it's already a less than probability. So go to the table. We're not on the positive table now, so we have to scroll up to the negative table. So we're going to walk up to negative 1.89 all the way over here, so it is 0.0294. .0294. All right, guys. So that is the end of the video. Please, please, please let me know if you have questions. I know that mods 4 and 5 were tough for a lot of people. Like I said, stay tuned for the announcement, or go check the announcement. I'm not sure when it'll be up, but it should be up very soon. If it's not already up as you're watching this video, it probably will be, though. And the announcement on, just check that announcement out. And yeah, please, please, please let me know if you have questions. Ask them wherever you need to. Email, discussion board, whatnot, or ask a peer or anything like that. All right, thanks so much, guys. We'll see you later. Bye.